you made it to part 2. I mean, part 1 of part 2 or whatever I'm talking about. All right, this is the August 2017 exam. I am going to do problems. Oh, come on now. This is I am Mr. Key, Mr. Answer Key. These are problems 13 through 24. If you need the 1 through 12, well, you're going to have to find that video. Maybe I'll put that in the show notes. By the way, all of these can be found at www.either.nkinfinity. You'll notice my intro has changed, or you can go to Mr. Krause Math. Mr. Krause Math, all one word, MrKrauseMath.com. I'm going to be changing back to myself because our school district decided that all this hard work that we're doing cannot be put into a business and make a kind of little bit extra money. Whatever, it is what it is. Let's get started. By the way, if you have not tried these problems on your own, let's go all through. If you have not tried these problems on your own and you're just here to copy or to cheat, and you have to learn to struggle. Okay? You got to put yourself in a testing mindset where there's not a little talking animal over your shoulder going, next you're going to do this, and why don't you try this, and you could use the calculator. You got to learn to do that on your own. So hopefully you've done that. If you have, we're in great shape. Now, as we go through this video, if you haven't watched my videos before, I always try to show you 1 or 2 different ways to do this one. And this one in particular, I'm really trying to show you how to drink coffee. I mean, try to do the problems a couple of different ways so that you can arrive at the solution. So let's get through this one. This is question number 13. Which expression is equivalent to this? Now, notice we're doing division, so you in your mind should be saying long division. This thing over here always confuses, like, what does that mean, Mr. Krause? Well, if you're really smart, you remember, if we plug in 1/2 here, we get 0 in the denominator. You're not allowed to have that. So really all that is a restriction on the domain. It's what the domain is. It's all reals except for x cannot equal 1/2. Okay, that's what that is. So they want us to do long division. All right, so I'm going to go 2x minus 1 long division into this. Now, here's another problem. Did you see that there's something missing here? Do you see there's no squared term? That's a little weird. You can't do long division with a missing term. So we got to put one in. We'll put in 0x squared plus 9x minus 5. All right, so long division is actually pretty easy. You're going to try to match this to this by multiplying by 2x squared. Everything have 2x squared? Yep. Now, remember, you got to multiply by both. So 4x cubed minus 2x squared. Now, here's the one thing most kids forget. We have to subtract. So I'm going to turn this into subtraction. This turns into addition. So I get 2x squared. Bring down the 9x. So what am I now? I've got to match 2x squared with 2x, or 2x with 2x squared. Well, that's just x. How many of them got x plus x? All right, we're done. There's the answer. I'm not kidding. That's probably the answer. But let's check it out just to make sure we get it, because it may not be. Maybe I screwed up. 2x squared minus x. Take out that negative pen. I get 10x minus 5. Well, I got to match 2x to 10x. Well, that means I need a plus 5. Oh, look, I got a plus 5 here. 10x, and then that's 10x, and then positive times this negative is negative 5. Subtract plus 0. Wow, that's nice. That's nice. So there's my answer. Now, wouldn't it be great if there was a way that I could do it so that I could say, pa-chim, star it. It's all perfect. Of course there is. So let's go over to the calculator. Ooh, we got all this crap in here. Red X, go away. We don't want you. We're going to take any number like 2.3654, whatever I just said. Control var. We're going to store this in X. Again, if you have the TI-84, you also have a stove feature. There's a button down here that says STO. You can do the same thing. And what we're going to do is type in the original problem. So control division, 2x cubed, 2x cubed. Make sure you get out of cube mode. Plus 9x minus 5 all over 2x minus 1. Shabam, there it is. Get some silly answer. And then the answer we came up with was 2x squared plus x plus 5. Shabam. I done screwed something up. 2x squared plus x plus 5. 4x cubed. Oh, there it is. Got to actually put the right problem in. This is 4x. There we go. Now they match. If you actually type in the right numbers, they match. Those are supposed to match. If those match, there's your answer. So I know for certain I got that one right. Star it. Not going to look at it again. Now this problem, woohoo, cuckoo for Cocoa Puffs. This one's kind of tough. Remember, normally what we do is to find the to find the inverse, what we do is we say, okay, switch x and y. All right, I'll switch x and y. So I get x equals y plus 1 over y minus 2. Well, now I got to solve for y, and I got to get y all by itself. So I might want to try to cross multiply. Let's see, y minus 1 or y plus 1 equals x times y minus 2. If I distribute that, I get y plus 1 equals xy minus 2y. Excuse me, minus 2x. Now, what you got to do is you actually got to get the things that have y's together. So we're going to take this thing and we're going to slide it over here. So we get y minus xy equals negative 2x minus 1. Holy crap, that's a pain in the neck. Actually, I don't like the way I did that. What I'm going to do is, I'm going to do it this way. I'm going to move this y over. I think that'll be easier. And then I'm going to move this 2x over here. So when I do that, I get 2x plus 1 equals xy minus y. Do y'all see those steps I just did? That's a little weird. I know that's a little cray-cray. Little cray-cray. So we're going to add 2x, and we're going to add 2x here. So that's the 2x plus 1, and we're going to subtract y and subtract y. All right, now here comes some magic. The left side is 2x plus 1. I told you I'm going to do this using a calculator in a minute, but this is the algebra involved in this. On this side, I'm going to factor out a y. When I factor out a y, I'm left with x minus 1. All right, now I solve for y. X minus 1, x minus 1. So there is the inverse. 2. Now, let's take a look and see what this would look like graphically. And you should try to get in your mindset that I can do things graphically very, very, very easily. Control division, let's go through the first one, is x plus 1 over x minus 2. There's our original. Now, if you remember correctly, inverses are reflections over this line y equals x. So, I need to find the one that is, if I reflect it over the red line, I'm going to get the blue graph. So let's try, I'm just going to show you the first one. The first one says x plus 1 over x plus 2. So control division, x plus 1 over x plus 2. And you're going to see, are those inverses? Like if I reflect this black one over this red line, do I get the blue one? Not at all. Not at all. So that's not it. So I'm going to press tab and put the original one, which is 2x, and then this would x minus 1. This is the answer I came up with. This is choice 2, correct? Now we're going to see if we see reflections or not. Oh, wait a second now. If I reflect this point in this axis, don't I get blue? You see how it goes to this point of intersection to it? Inverses have to go through that point of intersection as well, if they have a point of intersection. All right, there it is. That's a graphic way and an algebraic way. Algebraic was, that was rough, but graphic wasn't that bad. All right, which expression has been rewritten correctly to form a true statement? Well, all right. this is another one we're going to eventually end up starring. But let's just try number one. Let's see how it works. I'm going to double distribute. I'm going to deal with this side. I'm going to double distribute all that stuff. So I get x squared plus 4x plus 4. That's this piece. Plus, that should be a 4, plus 2x plus 4 minus 8. Does that equal, and then I'm going to distribute this x. X squared plus 6x. All right, if I clean up the left side, I get x squared, 4x. Wow, this is ugly. This should be plus 4. And then minus 8. So 4x and 2x make plus 6x. Positive 4, and negative 8. They just cancel each other out, and I get x squared plus 6x. So I'm going to tell you right now, there's the right answer. I believe there is the right answer. But why not take 30 seconds, come over to the old Taschenrechner. That's a really bad way of saying calculator in German. It's not a bad way. It's just I sounded bad. Taschenrechner is German. So 2.343. I don't care what. You don't like that? Pick 8.569. It doesn't matter what number you pick. Store it into x. Psh, bam. Now this is a pain in the neck. I'm not going to lie. Parentheses x plus 2 parentheses squared plus 2 parentheses x plus 2 minus 8. Do not use the equal sign. Just type in enter. Now we type in the right side. The right side is x plus 6 parentheses x. Shabam. There they go. They match. Star it. Nailed it. Definitely right. Ooh, this question. This question was good. I like this question. All right. This is a great question. All right. So New York conducted a study in 2004 in New York City and found that 212 of the 1,334 participants had hypertension. Now, is this a means or is this a proportion? Now, you can look at the answers or you can see that it says proportion here. But just remember, if it doesn't say that, you know that a proportion is a yes-no question. Do you have hypertension? No. Do you have hypertension? 5.8. That doesn't make any sense, right? I don't even understand what that means. So yes, it's a yes or a no question. So it is definitely a proportion. So I want to know what my p hat is. Remember, p hat is that one value we're going to use to represent the mean of this particular sample. Not in general, just this particular sample. Not sure what that is. Come over to my calculator. I go 212 divided by 1,334. 0.1589. 0.1589. So that's my p hat. That's my sample proportion. Oh, all right. So I know it's not these. So now it's got to be one of these things. Oh, margin of error. And we want a 95% confidence interval margin of error. New York State, you crushed me on this one. All right, so the first thing we got to do is figure out our sample or our standard deviation of our proportion. And if you remember correctly, that formula, which, why don't they give this formula on the formula sheet? I mean, they give some really stupid formulas on the formula sheet. This formula is on the AP statistics formula sheet, but not on New York State's. But you got to know it, so you got to know it. So it's P times 1 minus P. Quit whining about things, you just got to learn it. All over N. All right, so we'll figure this out. 0.1589. I guess I probably could use 0.16 if they gave that to us. Minus 1 minus 0.1589. I'm going to show you how I'm going to fix this on the calculator all over how many were asked. This is not the number of trials or the number of simulations. It is the number of people that were asked. Because remember, as the number of people we ask increases, the standard deviation decreases, not the number of trials. So in this case, the number of people asked is 1334. I do it repeatedly, 100 times, but it is 1334. By the way, they didn't even need to give this to you. I don't even know why they did. I'll show you why how we can figure this out in a minute. Graphically as opposed to here. My guess is most kids did this graphically without the proportions or without this formula, and I'll show you how to do that in a second. So we're going to divide by 1334. And I get that. But first thing I'm going to do is store this thing into P. Control var P. Where's P? P. Enter. So control division. P parenthesis 1 minus P over 1334. Boom. Oops. I didn't like this P times. Sometimes you gotta put times in there. All right, I get that. Now that might just make you jump on this one because you got 0.01. Except that a standard deviation with a 95% confidence interval. Now for New York State uses 2 for a standard deviation of 95% because they like to simplify things. The standard deviation for this is really 1.96, but for New York State we're just going to use 2. And your margin of error is going to be plus or minus, remember it's Z star times standard deviation of your proportion. So in this case, our Z star or our Z value for this is going to be 2 times this value we just came up with. So in other words, we just got to multiply this thing by 2 and we get 0.02. So the answer in this case was 0.02. Now after I've said all of that math and I've done all of that crazy stuff, would there be a more fun way or a more simplistic way, by the way, it's not choice 1, would there be a more simplistic way of doing this just using the graph? Sure. If you've run this simulation, then the center of the spread should be your mean. In other words, this should be my mean, 0.16. These two are the only possible answers because my p hat goes right here. All right. 95% confidence interval means I should be able to cover and get most of these. If I take 0.16 and I add or subtract 0.01, I get 0.15 to 0.17. Okay. Is that 95%? I don't think so. Right? We want to get out here. We want to get out somewhere out here. This would give us about 95%, right? We got a few out here and a few over here, but we got 95%. So clearly, this would be the better answer, choice 2. Okay, and that's doing it without using all those crazy formulas. And I think that's why they gave you the graph, because they don't think you're smart enough to memorize this formula or know how to use it. You know, they go the cheap way out. I don't like that. I really don't like that. But anyway, that's that problem. Alrighty, kids, let's keep going. Which scenario is best described as an observational study? Now, an observational study is quite simple. It is you are not in the collection of data directly. It's either you're watching something that's happened or you're observing something that's already transpired. In other words, somebody else has already collected data or there's already data collected and you're trying to look at that data and analyze it. Generally, you're looking for an observational data. You're just trying to look out there and see what's going on, but you can't be interjected into the scenario, right? So, for a class project, students in health class ask every 10th. Oh, okay. See right there. If I'm asking people something, that's not observational. That's a survey, right? I'm asking people questions. That's a survey. That doesn't make any sense. I am involved. I can't be involved in the collection of the data at all. A social researcher wants to learn whether or not there's a link between attendance and grades. She gathers data from 15 school districts. Okay, that could be it. She's gathering the data from the districts. She's not really interjecting herself or and depends on how that data was collected. My guess is they're probably just looking in the computer system. If you're going to look at the computer system and see how it goes, that you're probably right. So that's a possibility. A researcher wants to learn whether or not there's a link between children's daily amount of physical activity and their overall energy level. During lunch at the local high school, she distributed a short questionnaire. Nope. She's asking. That's another survey. She's asking. 60 seniors taking a course in advanced algebra concept. Yeah, why would anybody want to do that? Randomly divided into 2 classes. One class using a graphing calculator and the other class never using a graphing calculator. This is a controlled experiment. Anytime you're going to take and break 2 groups up, one gets the treatment and one doesn't get the treatment, that's a controlled experiment. That's not this. That's a simple one. There you go. Moving on. Which of the following sinusoid? Oh, I'm so special. I said the word sinusoid. Okay, guys, it's the sine curve. Don't go crazy. Has the greatest amplitude. Now, the one thing you got to remember about amplitude is that the distance between the midline and the top, the peaks and the valleys. You got to find the midline. So the midline in this one, the top is 7, and the bottom is 3. So that's 4, so we're going to go up 2. So here's the midline of this one. So my amplitude here would be 2. Let's try to find this one. The bottom is -5. This looks like a good possibility right here. And the top is 3. That's 8. So we're going to go up 1, 2, 3, 4. This would be the midline right here. So my amplitude here is 4, so this is out. If you remember correctly, the number in front of the graph, this right here, whether it's positive or negative, is the amplitude. Doesn't matter if it's positive or negative. This is 3, that's not 4. Oh, there's a negative right there. That negative is really just a reflection. So instead of going, remember, instead of going up first, it goes down first. But the 5 is the amplitude. So hopefully you picked that one and didn't get thrown by the fact that it had the -5 there. All right. Consider the following system of equations. The 2 solutions of the systems can be described as. Okay, so what we're going to do is we're going to do this 2 ways. We're going to do it graphically and we're going to do it algebraically. Oh yeah, we're going to do it algebraically first after some coffee. It's cold. Yes, it is. So, the easiest way to handle this is to solve this one for y. So if this was a part 2 question, you have to solve this one for y by bringing y over there and then the 4 over there. So I get y equals 2x minus 4, right? Positive y on the right, negative y on the left, whatever. So this is y. Now we're going to plug that thing into there. So what we get is, let me give myself some room here. What we get here is x plus 3 squared plus, now instead of y squared, since this is now y, we're going to replace it with this thing, is 2x minus 4 squared equals 8. And we're going to solve that. So this is x squared plus 6x plus 9 plus, now double distribute this. You know, this one you may want to write twice, 2x plus 4. Maybe that's more helpful. You're going to get plus 4x, and then it's, oops, it should be minus. So that's minus 8x and minus 8x. That's minus 16x, and then plus 16 equals 8. Since this is a quadratic, everything comes to the left side, or to the side where you're going to make your x squared positive. Let's see, that's 5x squared. Minus 6, plus 6, so it's minus 10x. And then, let's see, that's plus 25. These two make 25. 25 minus 8 is 17. Okay. Now, at this point, to answer this question about these things, I really just need the discriminant. I really just need b squared minus 4ac. So I'm going to do that real quick. B squared is 100 minus 4 times 5 times 17. And I get 20 times 17. Oh, I'm not doing that in my head. My brain's too tired for that one. 100 minus 4 times 5 times 17. Negative 444. Now, if you remember correctly, the discriminant is this thing under this radical here. Negative 444. Well, if that's negative, then aren't the answers going to be imaginary? The only way we're going to get that is imaginary. The other thing I could have done at that point is to go over to my graphing calculator. I'm going to show you another way to do it, this way to do it here, and go Menu, Algebra, Poly Tools, find the poly, but we're going to choose Complex. I don't know why I just canceled. I sorry, burped at you. Choose Complex, and the numbers were 5, negative 10, 5, oops, 5, negative 10, and 17. And then it gives you imaginary answers. But having said that, probably the best way to go about doing this. Oh, yeah, and this supposes you have this calculator, because the only way you're going to be able to do this on this calculator is this way. Go graph. Go to graph mode. And the first one's not hard, but what you need to do is you need to backspace and choose relation. And our first relation is 2x minus y. 2x minus y equals 4. Should be just a line. And then tab. And our relation is, next one is x plus 3 parentheses squared plus y squared equals 8. Now, as you graph it, do you see any solutions, or do you have to imagine there's solutions? There's no solutions. There's no real solutions there. That means the solutions have to be imaginary. You have to pretend like they're there, because they're really not. Well, this one I probably would just, here's how I would do on this one, which is not a factor. Okay, so if these are factors, then x equals negative 2 is a root. In other words, if I plug it in here, I should get 0. X equals negative 4 is a root. I should plug it in here and get 0. X equals 6 is a root. X equals 7 is a root. So these ones I would just come over here and grab my calculator, because this thing is not factorable. At least not the way I see that it's factorable. I don't know any pattern for factoring unless you go crazy on this one. I would just come over to your calculator and I'd say, okay, do you understand what a factor means? Oh, okay. So if it's a factor, then negative 2 should be a root. Negative 2 control var x. And then it's x cubed. Get out of cube mode. Minus 11x squared plus 16x plus 84. Should be 0 if it's a root. Boom, there it is. The next one I got to test is negative 4. Negative 4, control var x, enter. Don't retype that crap. Ah, that looks like it's my answer. But I still want to test. I want to test these other ones to make sure I have this right. So 6, control var x. Yep, 0. And then the last one I want to test is 7. 7, control var x. And they're all zeros. Boom, there it is. Another way I could have done this with this calculator is probability algebra. Solve the poly tools. Boom. Now it's a third degree polynomial. Click OK. And it's 1, negative 11. Negative 11. 1684. 16 and 84. Boom, there they are. Negative 2, 6, and 7 are your roots. That means that comes from x plus 2, x minus 6, and x minus 7. There is the loser, which is actually the right answer. A ball is dropped from a height of 32 feet. It bounces and rebounds 80% of the height from which it was falling. What is the total downward distance in feet the ball has traveled up through the 12th bounce? This is a geometric sequence. You're going to take the first one, and we're going to multiply by 80% to get here. And then we're going to multiply by 80% to get here. And then we're going to multiply by 80% to get here. Well, if you look up the geometric sequence formula, a sub n is equal to a sub 1, the rate to the n minus 1. Okay? So, in other words, my first term is 32. My rate is it's coming back 80% to the n minus 1. Now, what I could do right now is figure out what it is for 1, figure out what it is for 2, figure out what it is for 3, figure out what it is for 4, for 5, for 6, for 7, for 8, for 9, for 10, 11, 12. Holy mackerel. And then take all those numbers and add them up. You're going to be here for an ever. It says the total downward distance in feet the ball traveled. Starting in here, downward. Okay, so I could do that, or I can just use my big E, my big summation, n equals 1 to 12 of my geometric sequence. 32 times 0.8 to the n minus 1. Then I just come over to the calculator. Let me clear this up. And the big E is on the key of everything. It's right here, the key of everything. And you go to your big E. And you do n 1 to 12 of 32 parentheses 0.8 raised to the n minus 1. Enter. Boom. 149.004. Boom. There it is. Now, there's another formula, I think, on your formula sheet. I hate that formula. Oh, because to me, it's a geometric sequence. Or, you know, why aren't we just using this geometric formula right here? I don't know. And I think it's, God, I forgot. See, this is how bad I am. I'm going to go over here. You know what? This might have the formula sheet in it. Maybe. Oh. I forgot. I forgot. It's right here at the bottom. So it's this silly formula right here. A sub 1 times a sub 1 to r to the n minus 1. It's such a ridiculous formula. But whatever. I don't even know where it comes from. You know what? I haven't even given it any brain power to figure out where it comes from. It's the sum of a geometric series formula. I don't know where it came from. But it's a sub 1, which is 32, minus 32 times 0.8 to the n. I think it's 12, all over 1 minus 0.8. Now, this probably will give us the same result if I type that in right. So it's 32 minus 32 parenthesis 0.8 parenthesis raised to the 12, all over 1 minus 12. Up 0.8. Whatever. Like, to me, the geometric series formula is a much, much, much cleaner, understandable thing. This is a sum of a geometric. This is the sum of a geometric series formula. I don't know why. Whatever. There's the right answer. Let's move on. A public opinion poll was conducted on behalf of Mayor Ortega's re-election campaign shortly before the election. 264 out of 550 voters were going to vote for Ortega. The rest said they would vote for his opponent. All right. Probably going to know what that is. 264 divided by 550. I get 0.48. I guess I should have looked at the answers. So 0.48. So there's the probability of picking Ortega. Wait a second. That's not the probability of picking Ortega. That is the percent of people polled in the sample that said they would pick Ortega. So, I hope on your calc test you have a highlighter. Which one of these is least likely to happen? Let's see. There is a 48% chance Mayor Ortega will win the election. That seems like it's the wrong answer right there. That doesn't make any sense. Just because one sample said that doesn't mean it's going to happen, right? Just, I can go out and sample people. Hey, what's the probability that everybody's going to go watch the new Marvels movie this weekend? And I found out there's 30% that are going to go watch it this weekend, right? Does that mean 30% are going to go watch it? I don't know. I have no idea. The point estimate, or the p-hat of voters, and the p-hat, if you remember correctly, I don't know if you did my stat stuff or if your teacher did this, your p-hat is basically your, it is a single number used to estimate what the population is being. And because your sample is large enough, it really is a true estimate of the population parameter p. And that's equal to 0.48. So that's actually true. If it's most likely that between 44 and 52% of voters will vote. Well, if you got a 48%, I'm not really sure where these numbers come from. It is most likely, my guess is they probably did this thing, 0.48 times 1 minus 0.48 over 550. Let's see what that is. I'm just curious. So 0.48 times 0.52 over 550, and you get that. So 0.02. So if I add 0.2 to this, and I add 0.02 to this, and I subtract 0.02, and I subtract 0.02, which is what we came up with, that's 95% confident, right? Well, that seems like they're trying to create a 95% confidence interval. So that seems like it kind of makes sense. Due to the margin of error, an inference cannot be made regarding whether or not Mayor Ortega or his opponent will most likely win the race. Absolutely, this is true, right? Because if it's a margin of error, this really might be down here at 0.44%, which means the competitor would get 0.56%. Or maybe Ortega's up here at 0.52 and the other person's at 0.48. But that margin of error, we don't know if he's going to be above or below. So that one's not true. This is the one that's not true. This one doesn't make any sense. I mean, these are all true. These ones all here make sense. All right? All right. We are almost done. We are almost done. At least with the multiple choice. What do you do when you have an exponent raised to an exponent? You multiply those exponents. But this exponent goes here, and this exponent goes here, and this exponent goes here. Now, this is another one we're going to be able to star at the end that we know we got it right. But we're going to do it algebraically first because this could be a part 2 question. So, what do we get? We get negative 54 to the 2/3 power times, now x, now what you got to do is you got to multiply 9 times 2/3. Well, if you do that in your calculator, you'll get 18. If you do it in your head, it's 18 over 3, but it's x to the 6th. All over y to the 4th times 2/3. Well, if you do that, you get y to the 8/3. So how many of these have x to the 6th in it? This one does, this one does, this one does. They all do. That's kind of useless. All right, so the x to the 6 actually doesn't even come into play in this thing. So let's figure out what these things are. This one's the tough one. This one is going to be the tough one. Let's see what we got here. This is equal to the cube root of negative 54 squared. Right? Because the denominator is the cube. So if I did this, the cube root of this would be negative 27 times 2 squared. The cube root of negative 27 is negative 3. And I can't do the cube root of 2. So what I end up with is negative 3 cube roots of 2 squared. Now I got to square everything. So if I do that, I get 9. Negative 3 squared is 9. And this cube root of 2 squared is really the cube root of 4. Ooh, man. Notice there's no imaginary numbers, so no imaginaries. At 9. So these two are the same on top. Now we just got to take care of this. This is the cube root of y to the 8th. Now y to the 8th can be written as y to the 6th times y squared. So what is the square root of y, or cube root of y to the 6th? Y squared. So I need the one with y squared. So this is the right answer right here. Woo! That problem's bad. That's crazy. All right, let's do it the cheating way. I don't know, I say cheating. I just say we're going to use it to check our answers. So I'm going to take any obnoxious number that I have, and I'm going to store it into x, 6.35. And I always pick positives, but I pick weird numbers. The only reason I pick weird numbers is because that way you're probably going to not run into the undefined situation. 8.564, we'll store that into y. And oops. Store that into y. All right. So now I'm going to type in the original. The original was parentheses, division, negative 54 x raised to the ninth over y raised to the 4th, all raised to the 2 over 3, some ridiculous number. Now we're going to type in our answer. Control division 9x raised to the 6. Now cube roots of, we got to do cube roots of. That's this one. Cube roots of 4 over y squared cube roots of y squared. Same obnoxious answer. There it is. We start, we're good, we're done. All right, last problem. Last problem. Oh my God, let's go. The Ricketts decided to set up an account for their daughter to pay for her college education. The day their daughter was born, they deposited $1,000 in the account that pays 1.8% compounded annually. All right, so if I just use this, then my formula would be very simple. It would be 1,000 times 1 plus 0.08, 018 to the n. That would be my formula. If it was just that, that would be it. Beginning with her first birthday, they deposited an additional $750. So we're going to add $750 after her first birthday. Oh, and each of her other birthdays. Which expression correctly represents the number of money after n years? Ooh. So you might get fooled into thinking it's this one because we added the $750, but no. You really might get fooled into thinking it's this one because we're going to add $750 every year. And that would almost be the answer, except at the end of the first year, you're going to have like something like $1,018 in your account, plus $750. So $1,768, and then you're going to earn interest on that. And then you're going to interest on the next $750 and the next $750. If you do it this way, this is a linear addition of $750n. This is a very, very tricky question because this is a really, I'll bet most of you picked this one because you're going to add $750 every birthday, and that is the classic, you're adding 1.8% per year kind of stuff. Okay, that's highly susceptible. You know, you might think that might be the answer, but it's not. So, and by the way, these are the explicit ways. We're now going to go into the recursive ways. And so here's how it's going to work. You're going to set your first values equal to 1,000. And every subsequent one is the previous term, which is a sub n minus 1, you're going to take whatever that is and you're going to multiply it by 1.018. That's the 18% increase. And then add 750. Now, if I did that on my calculator, if I did that on my calculator, 1,000, and I do times 1.018 plus 750. Now it's 1768, like I said a few minutes ago. But then I'm going to take that and multiply by 1.018. So now the whole 1768 is getting the interest plus the 750, right? The 750 just doesn't keep getting added without interest on it. And that's the tricky part of this question. This is a bad question. It was a really great question, but very difficult. I like to call these babies 100 busters, right? These are 100 buster questions because you're going to do all you can and you're, well, so the answer is this one, right? It's not 750N. That would be crazy. So there's the answer. Tough question. Anyway, hit subscribe, hit the like button. Let me know how you do. And if you get 100, let me know. I'd love to know about it. Put you on my wall of fame at MrKrauseMath.com. Catch you all on the flip side. Goodbye.